Okay guys, so we have added and we've subtracted polynomials. So we're moving on to multiplication over the next couple of days. So what you should do is I would like you to pause the video, try this warm up if you can. I'm going to do it and then talk about it. All right, so what I did is I did from comes first. So it said subtract f of x from g of x. So I wrote g of x minus f of x. I did my keep, change, and then I combined my like terms. Okay, as far as addition and subtraction goes, this would probably be the most difficult type with the x, y variables. So do the best that you can with this one. So with multiplying, we have to review some of our basic laws of exponents. This is all review, and even the whole concept of multiplying is not new. You've seen this before, so hopefully none of this is new to anyone. When you are multiplying common base variables, so x's or y's, you add your exponent. So if we have x to the a times x to the b, we get x to the a plus b. So over here is what you do. You keep the base and add the exponents. So here are some examples. X to the fourth times x cubed is x to the seventh because 4 plus 3 is 7. For the next one, we have x to the negative fourth times x. So what you have to remember is that anytime you have a variable with no exponent, there's assumed to be a 1 there. So when I add negative 4 and 1, I get x to the negative third power. And then x to the eighth times x squared. When I do 8 plus 2, I get x to the 10th. So starting off with basic monomial terms that have coefficients, you would take your coefficients and you'd multiply them. So 2 times 5 is 10. And when we multiply c squared times c to the negative third, the rule says to add the exponent. So I'm going to take 2 and negative 3 and add them. So I keep the variable as c. I do 2 plus negative 3 and I get negative 1. Another rule is a power to a power rule. So that means if we have a term with an exponent raised to another power, like you see here, x squared to the third, you keep the base. So we're going to have an x, and now we multiply the exponent. So I'm going to do 2 times 3, which is 6. When I have x to the fourth squared, right, I'm going to do x to the 4 times 2, which is 8. That's a power to a power rule. Another rule, the zero rule. Okay, this is going to come up a lot in the next few weeks, the zero rule. Anything to the 0 power always equals 1. And the nice thing about this rule is that if you forget it, you can just put something to the 0 power in your calculator and you'll see that you'll always get 1. It doesn't matter if it's x to the 0 power, 6 to the 0 power. I could even have 1,000 to the 0 power. Okay, anything to the 0 power equals 1. All right, so let's just start off basic. This is 5x squared times 2x cubed. So the rule says to multiply your numbers. So 5 times 2 is 10. And I'm multiplying this and this, but the rule for multiplying common variables says to keep the base and add the exponent. So 2 plus 3 is 5. Down here, I've got negative 3 times 6. I multiply my numbers. That gives me negative 18. Okay, and now my common bases, okay, so I have x to the fourth and x to the first. I'm going to add 4 plus 1, which is 5. But I also added in a y variable. So y to the first times y squared is y cubed. So rather than having a separate day of function notation, I'm just incorporating it here. So this says f of x equals negative 2 and g of x equals 3x cubed plus 6. Find f of x times g of x. So I'm taking this f of x and multiplying it by g of x. So what it looks like is negative 2 times 3x cubed plus 6. So now I have a monomial times a polynomial. In the previous one, I just had monomial times monomial. So what I'm going to do here is I'm going to take this -2 and I'm going to multiply it by the first term and the second term, okay? Also known as distributing. So here I get -6x cubed minus 12. For the second example, f of a is 2a and g of a is 6ay squared minus 4a. And I'm going to multiply these. So I've got 2a times 6ay squared minus 4a. And again, I have a number outside parentheses, so I'm going to distribute, okay? And in distributing, I'm doing that multiplication. So 2a times the first term ends up being 12. This is a to the first, a squared, y squared, minus 2, so 8a times a is a squared. So here's another example. So this one, you could do power to a power rule, but because it's squared, I like to show this one like this. We've got -2x cubed y squared, which means times itself. So I'm just going to write it again. I feel like sometimes this is easier for people to see. So now I'm just going to multiplying two monomials. I'm going to do -2 times -2, which is +4, x cubed times x cubed, which is x to the 6th. Okay, remember we're multiplying, but the rule is to add the exponents. And then I have y times y, which is y squared. All right, so for this last one, okay, I made these all really similar so that hopefully you see the difference. It says match the following to the answer. So basically, if I were you, I'd probably pause it before I see what the answers are, but okay, when I multiply here, -3x squared times 6x is -18x to the third power. So I know it's not that first one, okay, and I know it's not that second one because the second one has a +18x to the third. So it's that one there. Then the next one, -3 times 6x squared is going to be -18x squared, because I don't have any other x to add. So I know that's that one, which means that the last one, A, has to be this one, but let's double check. That would be 18 cubed plus 6x to the 5th. Okay. All right, guys, go ahead and try the delta math. Hopefully you're able to complete that.